Hi friends, in this video we are going to explain how to use two-pointer sliding window to solve the current problem. So first I'm going to look at the problem statement, and then I'm going to explain the logic behind two-pointer sliding window method with slightly some abstraction, and then we share the code. So basically we are given a string s, so we want to return the maximum length of a substring such that it contains at most 2 occurrences of each character. So first I want to point out that, so this problem says that in the substring, the maximum frequency would be at most 2, right? That's one point. Another point is that you can generalize this 2 to be a general key, right? So this is the problem statement. So here you can see the first example, you can use this one. So here you have 2 B's, and then you have C and A. And in the second one, so you have 2 A's, but you have 3 possibilities, but the length is invariant. And the length here is small. In other words, you can try brute force. But for this problem, a good practice is to use two-pointer sliding window method. So the logic is the following. Each substring potentially valid, it has a starting index and an end index. So basically we are going to fix the end index, let's call it R. Then we are going to find the smallest left index L, such that this string ending at R, starting from L, is valid. So in order to use two-pointer sliding window method, a order or monotonicity is crucial, which enables us not necessarily to start over. So basically, if I push the right index to the right, in other words, if R2 is greater than R1, then you extend the right, so potentially you can yield violating the maximum frequency. So it should push L to the right, or you can make it fixed. So in any way, so the corresponding L is no less. In other words, it's greater than or equal to the previous state. So this is exactly what enables us to use two-pointer sliding window method in this setting. So with that explained, I'm not going to go in too deep in the abstraction. Here we have a playlist in our channel on the applications in different situations corresponding to different problems in leetcode. You can check out that. So now let's look at the coding for this problem. First, I'm going to initialize a result variable. So this is what we are going to return. So the reason we use 2 is that the length is at most 2, and the key is here 2, right? The minimal result will be 2. So let's fix a left pointer, and then we use a dictionary called window to track the frequencies, and the maximum frequency is 2. So here I introduce this variable because you can generate in general key, right? And then we have a length of s. So now let's look at the right. So for R in range n, so the current character will be SR. I just isolated it so that we can save some typing. So in order to update this, the current is going to be the current frequency incremented by 1, right? So because originally with nothing, and then you add a new character, so this character is the trigger of potential violation. So we see this, we do push L to the right, so while L is less than R, and window, the current character, if it's violating this one, and so we're going to do this, L decremented by 1, so L is towards the right. So if you look at the specific step and also looking at in a loop, you will see in each one, the only possibility for violating the maximum frequency is the new character we're adding, because in the previous state, so it's corresponding to a valid substring, right? So then we are going to update this result. So because afterwards, so there are two possibilities. One is L equals R, but in this case, if I write like this, so result is larger because it's at least 2, so it's redundant. But in the other case, if this is validated, so in other words, index L and R correspond to a valid substring, so this will be the length, the difference of the indices plus 1. Then we can do the return. Let me first do a test and then submit. Yeah, so this is the case. And now you can actually also get the string. Let's see, I just use a temp. So original will be right. So then I can do a check. If I would say the length R minus L plus 1 is greater than result, then I set temp to be S, L, any and R. So I write R plus 1. So before we do the return, so we can print out the final state of this temp. That will be the string. So we can check that. So in the second example, one valid one is AA, and in the first one, so a valid one is BCBA, right? So with that said, I guess that's it for the current video. Thank you for watching.